Hello everyone, welcome to this video where we are going to go through leaf similar trees. So basically in this program we receive as input a tree and we are supposed to find out, in fact we receive two trees and we are supposed to find out if those two trees has similar leaf. What does that mean exactly? Let us take this tree for instance. The leaf of this tree is actually an array consisting of all of the elements of this tree. That means 6, 7, 4, 9, 8. This one, 6, 7, 4, 9, 8 is actually the array leaf of this tree. 6, 7, 4, 9, 8 is also the array leaf of this tree. Thus they are equal. That means we should return true. Here we have the array leaf is 2 3, whereas here is 3 2. So this one are actually different, so here we should return instead false. So pay close attention to this scenario. This one is just what we just saw here. We have similar value. I didn't put the value before the leaf because we don't really care about those value. Okay, and then here you can see that here we have 1 5 3 and here we are 9 5 3. So this is not a solution. Importantly, here we have 1 3, here we have 1 2, here we have 1 2 3. This is actually not a solution. So if you think of a recursion approach where you are going to take the next leaf and compare with the next leaf of the right, the next leaf of the left and compare with the next leaf of the right, make sure that you actually have a condition that is going to help you figure out if there is a left leaf that you didn't take in consideration, because that is what kind of blocked my first implementation. So given those two conditions or given those statements, how are we going to solve it? So for us to solve it, the first thing we are going to do is that we are going to write a helper function which is going to return us the leaf of a given node, and at the end we are just going to return those at the end we are just going to return the comparison in between the left leaf and the right leaf. So what will be our approach of computing the leaf? Okay, so now to compute the array of leaf, this is actually the core logic of our algorithm, the array of the leaf. We are going to proceed this way. We are going to say, okay, if we receive as input an element, if the element is actually null, that means there is nothing we can do, just return the previous result we're having. If the element has a left of null and the right of null, that means it is a leaf, so we add it to our solution. And then after those two conditions being stated, we are going to recursively return the leaf of the left and the leaf of the right, which we are going to append to our result. That means when we are going to be here, we are going to say, okay, are you equal to null? No. So you don't fall in the first condition. Is your left null? No. Is your right null? No. So we just recursively return the leaf computation of this. Here it will be the same. It will give nothing. Here the left will be actually null. So let us just make live update. Here the left will be actually let me take something. Let's pick. Here the left will be actually null and the right will be actually null. So this is actually a solution. So this one will be enter into the array. Okay, so don't forget that you are always returning the computation of the left and computation of the right. So the computation of the left here will be null, so it will just return the previous array that was 1, and the computation of the right will be null, so it will return the previous array that was 1. Don't forget that when you were here you return the left and the right. So after this being computed, now you're here. So computing this, we actually return you 5. Computing this, we actually return you 5, and then that array 5 should be append to your result that will actually give you this. So it's really important to understand that any sub element is going to return an array, and you need to combine that array to the result. And then lastly, going through this, we actually give you the tree. So given that we are aware of how we are going to compute, how we're going to code it. So like I was saying, you really need to start with a vector that will be like the result that will store the length of the node. And then now you need to check if the root is actually equal to null. You return the result. That is the scenario where you have like those elements. There's nothing to do, just need to return the previous list. If the left is actually equal to null and the right is equal to null, that is definitely I would say a lift. So if it's definitely a lift, so you just append it here. And more importantly, after this, you are going to make the left result take the left of the root dot left, the right result take the left of the root dot right. This actually is actually an array, because your function is returning a vector of integer. So all of the sub functions that you're going to call are also going to return a vector of integer. And then what you should do here is that you should append those results to the actual result that you have here. And then by appending this, depending on the function, the program you're using here in C++, to append, just say, okay, at the end of my result, I want to put all of the elements that I have in my left result. And then by doing so, at the end, you are going to have the list of the vector, the list of the value constructing the list of the value constructing the left element. So we just need to compare if the length of the root 1 is equal to the length of the root 2. If they are equal, yeah. So let's submit and see what it gives. Yeah. So this is how the program is performing. Just a few seconds, this program was performing 2 milliseconds. Now it's 7 milliseconds. Quite surprising. Now it's climbing to 10. Okay. So anyway, this was my approach of solving this. I hope you do enjoy it. Feel free to give me any input. I'll be really happy to interact with you regarding this. See you on the next video. Ciao.